Math 2415, Calculus 3, Section 13.6, Parametric Surfaces and Their Areas, Video 2. In the previous video, we defined what a parametric surface was. Basically, it was a vector function with two inputs, and so the x, y, and z components are all functions of u and v, where the region lives in a UV plane. And also said we're going to take a look at another example in the next video, which was not what I meant to say. In the next video, we'll look at an example. But first, I want to define what are called grid curves. When you are sketching a parametric surface or using technology to sketch a parametric surface, they are often sketched by graphing what are called grid curves. A grid curve is basically the image of a horizontal or vertical line through our vector function. For example, let's say that we take a region D and a point inside of it, u0, v0, and we look at the vertical line u equals u0. Now, I wouldn't go through the whole region. Well, the line would go beyond the region, but we're only considered inside of this region. If we take this vertical line through the point u0, v0, and its equation is u equals u0, and we send every one of these points through the vector function, then we're going to get a curve. And that curve may look something like this. I'm just making something up here. So this would be r of u0, v, because we're holding the u constant and letting the v go through all of its values. That's an example of a grid curve, in this case a grid curve of a vertical line. If we did a horizontal line, then the equation of the horizontal line would be v equals v0. And when we take every point on that horizontal line and send it through the parametric function r of u, v, we'll get another curve that also goes through that point. And that curve could be thought of as the function evaluated at a fixed v value, v0, but letting the u values run through all of their possible values. It's not uncommon in computer graphics to draw three-dimensional surfaces by sketching their grid curves. There's a nice little note on the bottom of page 799 about attempting to draw a sphere in 3 dimensions using grid curves, because if you don't, then you lose some of the equator, because if you try to define it as a function of x and y, you get these vertical tangent lines and you can't draw anything. But as grid curves, you can actually draw the whole thing pretty nicely. So think of these as level, I want to say level curves, but not quite. It's kind of like on a topological map where you connect all of the points in the plane whose outputs in the function have the same value. It's kind of like that, but upon further thought, actually it's kind of not, so just pretend I didn't say that. These are just the images of horizontal and vertical lines through the vector function to show you their grid curves on the parametric surface.